In class example 1.4.1, we're going to be sorting these numbers into rational or irrational numbers. Now, an irrational number when converted to a decimal form is a decimal number that does not repeat and does not terminate. So 0.3517823521 something. This is a non-patterned decimal number. I just made it up. And if I say ... it means it goes on forever. Now, a terminating decimal, no problem, something like 0.125. That is a rational number. And a patterned decimal, something like maybe 0.1111111. Now, even though this potentially could go on and on and on forever, this is a patterned decimal, okay? And so this is also rational. So this is irrational. We're going to mark it with an I, and we're going to mark rational with an R. So what we're going to do is we're going to take out our calculator and we're going to check a couple of these numbers and classify them as rational or irrational. Let's take for the first number the square root of 0.24. If I put the square root of 0.24 into my calculator, I'm going to get 0.4898979486 something. I don't know what the next set of numbers or digits are from my calculator because it only is going to give me to 10 decimal places. But if you can't see a pattern after the first, 3 or 4, or even 5 at the most, there isn't going to be a pattern that exists. Therefore, we can say this is a non-terminating, non-repeating decimal number when I convert it into a decimal form. Therefore, it's irrational. Next, let's take a look at the fifth root of negative 32. A bit tricky to find this one in your calculator to find the fifth root. We would hit the number 5 first, hit math if you have a TI 83 or 84 or even Inspire, I think. You would hit math and scroll down to where it has an X square root like this. And then we would hit enter and put in negative 32 into our calculator, and the actual answer we should get is negative 2. Now, negative 2 doesn't even have any decimal numbers. It's a nice whole number. So in this particular case, it does terminate. It terminates before or right after the number 2, and so it's irrational. 5 divided by 7, if I put 5 divided by 7 into my calculator, I can see that I've got 5 divided by 7, I'm going to write that down, 0.71428. And then I get 714. Now it says 3 here, but you can see that this is actually going to round. The other thing about a rational number is if I can write it as a fraction, then this pattern is going to repeat. I will get 714285, 714285, 714285. So this is actually a repeating decimal number, so this is a rational. Square root of 64, we know that. That's on our lovely perfect squares list, and the square root of 64 is just 8, and so 8 is a nice whole number. Therefore, it's not an irrational number because it has no decimal number that follows it. The square root of 16 divided by 49, we should recognize those two numbers as well. We know that 16 is actually on our perfect squares list, as is 49. So I could rewrite this as the square root of 16 divided by the square root of 49, which is the same thing as saying 4 over 7. And because it can be written as a fraction, it's a great thing. We know that this is going to be then a rational number. All right, let's take a look at the square root of 1/5. If I put the square root of 1/5 into my calculator, I get 0.4472135955. This is a non-terminating, non-repeating decimal, so therefore it is an irrational number. Now we know that 25 is a perfect square, but it's 0.25. Let's just double check what happens when I put in 0.25 into my calculator and I take the square root of that. I end up getting 0.5, which is not a coincidence. We know that 5 squared is 25. So 0.5 squared is 0.25. So this is a terminating decimal, therefore it is a rational number. The fourth root of 12 is our next number here. And when I put that into my calculator using that math key, if you have a TI-80 something calculator, you would put 4, hit math, scroll down to again that X square root button, and then you would hit in 12 and hit enter, and your decimal number should be 1.861. 209,718 something 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 something. And this again is a non-terminating, non-repeating decimal, so I can see that this is going to be an irrational number. 0.6 squared is actually just 0.36, very similar to 0.5 squared was 0.25, so that's okay. That's a terminating decimal, so that's rational. And if I put the square root of 3 into my calculator, we're going to see the square root of 3 quite often. I get 1.73205808. Again, this is going to keep going. I have non-terminating, non-repeating number, therefore it is irrational.